My question is, how did you discover that quarks in the how did you how did you discover that quarks in the protons cannot be separated? And how did you probe into the nucleus?
The question was, how did we discover that quarks can't be separated, and how did we probe inside the nucleus? Well, since we were theorists, we probed with our minds, relying on our experimenter friends to probe what went inside the nucleus by smashing nuclei together and seeing what came out. And among the rest, quarks didn't come out. Actually, what I was really interested in explaining was why quarks didn't interact, it seemed, when they were very close together. And remarkably, when we discovered a theory in which that was the case, in which the force was very weak at short distances, the same theory said that the force was very strong at large distances. So there was an immediate benefit from our discovery that we could provide a mechanism for the fact that you can't pull the quarks out of the nucleon. That wasn't our motivation, actually. It was a benefit of the discovery.
Thank you. Now UP Visayas in Miagao is ready to ask a question. Okay, I have the name of the person who wants to ask a question. An associate professor of biology, Professor Gilma Tayo. Her question: is there any new development in physics that can be used to solve global warming?
You know, is not one problem, but many problems. Some of the problems have to do with taking existing forms of energy consumption, fossil fuels, and somehow removing the CO2 so that we don't put it into the atmosphere. And there are methods, expensive methods, and I think physics, chemistry especially, can contribute to making more efficient methods of carbon sequestration. But beyond that, physics, chemistry will play a big role in developing new ways of producing energy which are much cleaner, like solar energy. And there is no question that there is a need for even basic scientific understanding and technology that will give us sustainable and clean energy sources. So there are many areas, but then there are other possible ways of tackling the problem, which could be considered if we knew a lot more about the planet, its climate, and the physical processes that underlay that. So there's no question that science in general, not just physics, biology, climatology, meteorology, geosciences, will all have an enormous contribution to make towards helping to solve this problem. But remember, it's not just the scientific tools, it's the behavior of people and of societies that will ultimately solve the problem.
Thank you. Yes, you please.
First of all, Dr. David Gross.
May we have your name, ma'am, please?
Yeah. My name is Theta Ponce. I graduated from the University of the Philippines so many years ago. So like Dr. Gross, I'm an alumna of this university. And I'm also in physics. So I'm very happy that you have come to our country, Dr. Gross. And we really looked forward to your coming. In fact, my students and I are here. No? Now, I'd like to ask you this question, because earlier in your lecture, you mentioned, no, in your introduction, that science is professional. and that everything is relative. Not like the truths of science are relative. Now, I'd like to ask you for a clarification. Now, because there are certain things that I'd like to mention later. The thing is, of course, you must have been referring to our understanding of physical truths, right? Because one thing I remember is that in the theory of relativity of Albert Einstein, one of his postulates there is that the laws of nature are true with respect to any frame, right? So that means there are absolute truths, the laws of nature. So that means that our understanding, it's our understanding of the laws of nature that are provisional, that are relative. Do you agree with me, sir?
I am a Platonist, I agree. Nature and its laws or regularities is something I believe exists, and we are trying to grasp it, model it, explain it, and so far every description and regularity which we call laws have been provisional and undergone revision or improvement, becoming better and better approximations to a reality that I believe is out there, exists. That might go on forever. So I think we're in agreement. Nature exists. It's our perceptions, our modeling, our understanding of nature that is provisional.
Thank you very much,
Thank you.
Dr. Gross.
Thank you. Now we have Manila. It's a remote point that's closer to where we are. Actually, I have the name of the person and the question in the prompter, so I'm going to read it for Dr. Gross. The question is by Dr. Roy Tumlos. Can you comment about the not so transparent fact that corporations do dictate the agenda of governments and not only of science? Won't they be critical in the solutions of the problems globally?
Absolutely.
Absolutely, he says. Thank you. Yes, please. The gentleman in blue, yes.
I'm Arnie Sikam. I am an ophthalmic physicist, physics of the eye. I'm an alumni and now based in the Netherlands. This is really a follow-up question with what Roy has asked, because in most professors and academicians, because of ethics, they are at a distance from active collaboration with industry. But with economics, then they play a major role. And most of the young scientists are trying to sort of be in between this collaboration. Do you encourage academicians to play active role in the industry?
Well, yes, of course. In my field, which is very basic science, I have the great advantage and disadvantage of working on problems which have no immediate practical use or application. So that's a great advantage because there's nobody who, no politician or university administrator or corporation understands what I'm doing, much less tells me what to do. On the other hand, it's harder to raise funds for such things. But in many areas of science, there is a very short time lag between discovery and application. And in those fields, cooperation of basic science and applied science. Science driven by curiosity and technology for the benefit of mankind are very closely linked and benefit enormously from mutual interaction. And in my university in Santa Barbara in California, there is in many areas of physics and engineering very close connections with applications of the new ideas that are generated. It's very healthy for the businesses, the corporate, and it's very healthy for the university investigators because they realize that it's only through that exchange that they can sometimes direct their research towards areas that might actually turn into something useful and beneficial. So I think such cooperation is excellent in general. It can have its dangerous effects on research as well and on academia, but it can be done correctly and well to the benefit of both sides. But my field is so far removed from application. That will come maybe 100 years from now, that I myself am not involved in that kind of activity.
Thank you very much, Dr. Gross. And that ends our open forum this morning. I realize that a lot more questions want to be asked today, but unfortunately that's all the time we've been given for the open forum. I'd like to thank everyone who joined us today in the theater through video conference and via webcast, particularly all the UP constituent universities in the different campuses all over the country. And to those who asked questions and raised very interesting points, thank you. Most especially, thank you, Dr. Gross, for giving us this opportunity to hear you and have this conversation with you. Thank you very much.